So they want us to find intercepts. They give us a function right there, and they conveniently factored it for us. We'll talk about that in a minute. And they ask us to find the y and the x intercepts. So remember, to find a y-intercept, you want to find f of 0, okay? So in this case, f of 0 is going to equal 0 minus 2, 0 plus 1, 0 minus 4, and then I'm going to have negative 2 times 1 times negative 4. I'm going to say the y-intercept is at 8. Now, if I'm interested in graphing it, it means there's a point somewhere up here at 0, 8. That is the y-intercept. Anybody asked? That's the y-intercept. I was looking to see how they wrote it. They just write it as the ordered pair like I have in the box. Okay, now we're going to find the x-intercepts. If you want to find x-intercepts, you take the function and and set it equal to 0. Okay? So I have x minus 2 times x plus 1 times x minus 4 equals 0. Now you might be thinking, oh, I'm going to have to multiply all those binomials out. It's going to be a mess. And then what am I going to do? Don't go there. It'll be much easier if we leave it factored. Because if we leave it factored, we can use what's called the zero product principle, the old ZPP. So when you have things multiplied together and you know it equals 0, one of those factors, either this factor or this factor or this factor, one of them has to equal 0. So we're going to say x minus 2 equals 0, x plus 1 equals 0, and x minus 4 equals 0. And that's going to give us 3 x-intercepts, 3 different x-intercepts here. We're going to have x equals 2 for this one, x equals negative 1, and x equals 4. So it's a lot easier if they give it to us factored, to be really honest. So for our x-intercepts, we're going to write the ordered pairs. 2, 0, negative 1, 0, and 4, 0. There are 3 x-intercepts. Remember, you can have lots of x-intercepts, and you might not have a lot, but you can. You can only have one y-intercept. That was a pretty fun problem.